Acetic acid from ethyne. Let us see molecular formulae of acetic acid and ethyne. Ethyne, carbon-carbon triple bond, and acetic acid. This is acetic acid, which is also known as ethanoic acid, and this is ethyne. This is also known as acetylene. In this lesson, we are going to learn preparation reaction of acetic acid from ethyne. Acetic acid from ethyne. So let's begin. Acetic acid is prepared from ethyne basically through two steps. Step 1. Ethyne gas or acetylene gas is passed in a mixture of 2% mercury sulfate and 20% sulfuric acid. Here, mercury sulfate acts as catalyst, this ion, and sulfuric acid acts as proton provider. Here, acetylene reacts with water of this mixture to form acetaldehyde. Acetaldehyde is formed when acetylene reacts with water of this mixture. Mechanism of this step can be shown in this way. Simple mechanism, that is water, from which we can write proton and hydroxide ion. Simply we can see proton combines with this triple bonded carbon and hydroxide ion combines with another triple bonded carbon. As a result, we can write this one. This hydrogen combines with this carbon, so this hydrogen. Then carbon-carbon triple bond turns into carbon-carbon double bond with this carbon, hydrogen and hydroxyl group. What is this? This is vinyl alcohol. This is also known as ethanol. Now, this ethanol undergoes tautomerism. Tautomerism has been discussed in detail in isomerism section. Here, it undergoes tautomerism in this way. Oxygen-hydrogen bond shifts here to form carbon-oxygen double bond. Then pi bonded electrons move towards this carbon. This carbon becomes negatively charged. At the same time, this hydrogen gets freed as proton. This proton combines with this carbon. As a result, this is obtained. Carbon-carbon double bond turns into carbon-carbon single bond with this carbon, hydrogen, carbon-oxygen double bond. Acetaldehyde is formed. Through this mechanism, step 1 forms acetaldehyde. Now let us see step 2, through which acetic acid is formed. Step 2. Acetaldehyde. In step 2, acetaldehyde is oxidized by air in presence of manganese acetate. This is manganese acetate or manganese 2 acetate, and this reaction mixture is heated at 60 degrees Celsius temperature. Then acetaldehyde converts to acetic acid through oxidation. This acetic acid is separated through distillation at 118 degrees Celsius temperature. In this way, acetic acid can be prepared from ethyne or acetylene. Let us see actual mechanism of the reaction. Mechanism of the reaction. Ethyne or acetylene. Here, catalyst is 2% mercury sulfate. This mercury ion makes a bridge between two carbon atoms, triple bonded carbon atoms, in this way. As a result, carbon becomes partially positive in charge. At the time, water present in the mixture combines with one carbon atom to form this one, mercury. Then here double bond, carbon, hydrogen, here hydrogen, here water. Oxygen forms bond with this carbon. That is why over oxygen positive charge develops. In this way, this positive charge disappears, and as a result, this hydrogen comes out from the compound, from the entity, and as a result, this is obtained: hydrogen, carbon, mercury. Here carbon-carbon double bond, then with this carbon OH group, and here hydrogen, this OH group. Then this entity undergoes tautomerism in this way. Here electronegativity of oxygen is 3.5, hydrogen is 2.1. So this oxygen hydrogen bond shifts here to form carbon oxygen double bond. Covalently bonded electrons move towards this carbon. This hydrogen gets freed as proton. This proton combines with this carbon. As a result, this is obtained: hydrogen, carbon, hydrogen, with this carbon, mercury, carbon-carbon single bond. Here carbon oxygen double bond, here hydrogen. This is obtained. What change occurs in this entity? That is, here carbon oxygen double bond changes to this carbon oxygen single bond. It becomes negatively charged, carbon becomes positively charged. With this oxygen, sulfuric acid acts as proton supplier. Then, because of this positive charge, This bond moves here to form carbon-carbon double bond. And finally, let us see what is obtained. This entity changes to this one. Hydrogen, carbon, here hydrogen. This hydrogen can be written here, carbon-carbon double bond. This carbon-carbon single bond turns into carbon-carbon double bond. With this carbon OH group, this hydrogen came from sulfuric acid. With this carbon, another hydrogen. Now, this entity undergoes tautomerism again. In this way, oxygen hydrogen bond shifts here, pi bonded electrons move here, this hydrogen gets freed as proton, this proton combines with this carbon. As a result, this is obtained: hydrogen, carbon, hydrogen. This hydrogen with this carbon, carbon-carbon double bond turns into carbon-carbon single bond. Hydrogen with this carbon. Now with this carbon, oxygen with double bond, carbon oxygen double bond. Through this mechanism, acetaldehyde is obtained. Acetaldehyde or ethanol. This ethanol is oxidized by air in presence of manganese 2 acetate, which is a kind of catalyst here. This catalyst catalyzes the reaction to form acetic acid. This is the mechanism through which ethyne is converted to acetic acid. This is all about preparation of acetic acid from ethyne. No more today. Thank you very much.